Hey everyone, today we're going to talk about the question merge sort. So for this question, we're going to sort a unsorted integer array into a sort integer array in a ascending order. So for the question, we can clarify the output and the input. They are both the int array. The input is the unsorted one and the output is the sorted int array with ascending order. And we can assume that in this array, the input array can be a null. Can be a NOR. So for this question, let's do the code right now. Let's do the signature of the question. So the output array in here is an int array, and we're gonna name it merge sort, and the input is a int array. Okay, so in here, let's do firstly, let's do a sanity check real quick. Like we said, the int array can be NOR, and in another case, the length of this array can also be 0. So in this case, we can just return array itself. And then we're gonna call a helper algorithm, also called sort. So in this helper algorithm, we're gonna need to put into the array we get in here and the left boundary and the right boundary of this array. And after that, we will get a sorted array. So let's just return this helper function. Okay, so I can write this private helper function here. The output type for here is, of course, an int array, and we can also call it merge sort. The signature is a little bit different. We got the left boundary and the right boundary. Okay, in here. As a recursive function, we're gonna decide what is the base case in here. So, okay, base case. So for this array, we want to split the bigger array into the smaller arrays and then merge this smaller arrays. While we only have one element in the array, so in the case is the left boundary is bigger or equals to right, which means we only have one array in the smaller array, so you can just return it. So in here we return the left element, the only one element in this smaller array. This is the base case. And then we want to do recursion multiple times to split this bigger array into a smaller one. We will get multiple, basically two types of int arrays. One is from the left side, we call it left array. So in here, we need to get also the variable mint. It comes from the range of the array. So the right side minus left side, which basically means the mid position of this array. And then we call this function and make it to two parts. One is from the left to mid, and the right part is from mid to right. Okay, right array, R-I-G-H-T, right array equals to merge sort array mid plus 1 and right. Okay, and then after we split the array to smaller arrays, we want to merge it, which is another helper function, which is another private function. We're gonna write later. We got the left array, right array, we merge them together. The output type for this function is also a int array, so we can just return it. So let's write the last function here. Okay, we got left array and another array called right array, A-R-R-A-Y. So in here, what we want to do is merge this two smaller arrays into a bigger one, sorted bigger one. So output type gonna be a int array, and the length gonna be the left, the length of the left plus length of right. So left array dot length plus right array dot length. Okay, in here, and then we're gonna use a few pointers like int I equals to 0, j equals to 0, and j equals to 0, and k equals to 0. I'm using those 3 pointers to point to one used for left array, another one used to right array, and another one used to the result, and let each pointer to point to one element in each array. I'm going to move the smaller one from either from the left side of the array or right side of array and right into the result and move forward. Let me show this as an example. So while I is the pointer for left array. So when I is smaller than left array dot length, and also j is smaller than right array dot length. While this pointers is under this range, let me move this one down below. Okay. Okay, we can see if we can find the smaller element from either side of the array. So let's see, the left array I pointer is smaller or equals to right array j, which means we found the valid one from left side, and now I'm gonna write it into the result. So result k gonna equals to left array I. And in here, I'm moving forward. So from, and in another case, the array I is bigger than array j. We can write the result k equals to another side's element. In here is j, and move j forward. And don't forget to move k forward every single time we write it. Okay. So out of the while left array is shorter or right array is shorter, we can continuing writing the result into result array. So for example, if only one array is still qualified of the length, we can write all of them into the result array. So in here, result k is equals to left array I moving forward, and k moving forward. And if the right array is longer, we're gonna have this left. Okay, and write all these left elements into the result array. Equals to right array j. Okay, and j moving forward, k moving forward. Okay, now we finished scamming all elements in the left array and the right array. We can just return result array. Cool. And we get the answer of it. Cool. We can analyze the time and the space complexity for the question, time complexity and the space complexity for this question. So the time complexity for this question, as we can see, each time we call the helper function, we want to split the longer array into 2 smaller array from the middle position, and then we merge them together. So as we can see in the merge position, we want to scan every single element in the left side array of and the right side array. Let me write a sample to make it more clear. So we got 4, 5, 3, and 2, and 1. Maybe one more 0. Okay, so we got 3 elements each side. The input is this unsorted array, and then we're gonna use left array, right array too. We're gonna split into left array and right array and merge them together. Okay, now we got this, and we want to maybe split a little bit more. Yeah, before we can merge them. And let's say we did it multiple times and multiple times, and we have one element here. And we want to merge them. So in every single layer of recursive function, there is an element in here. We need to merge them together. Okay, and we got the maximum depth of call stack is log n, which means we have 50% of the element each time until is 1 or 0. So the depth of this recursive tree is log n, and each layer we got n elements in this function. So the time complexity together gonna be the maximum depth of call stack, and each layer on time times the call stack log n layers. So total time is n log n. And for the space complexity, so as we can see here, the space complexity is we need to use the inter-array result to store the actual result in here. So, okay. So totally extra space used in heaps is AON, as this result array has all element from left side and the right side, and the rest time complexity is AON time. So together is one time. So together is ON time. Thank you, everybody. This is the solution for the merge sort. Let me know if you have any question. I see you next time. Bye-bye.